David St. Cross, and today I'm going to discuss the benefits of using client-server network environments. Computer networks today determine how organizations go about their business. Instead of using more dated mainframe technology, the majority of businesses benefit from using client-server network configurations. Using the client-server network environment allows businesses flexible expansion and operation, as well as spectacular interoperability between operating systems and hardware manufacturers. Hosts can act as both clients and servers depending on their configuration. For example, a computer can host information for other computers, and it can also request information from other hosts. An example of this is a peer-to-peer network. Peer-to-peer networks are commonly found in torrent sharing sites and in distributing files between other users. Although it is not widely adapted for use in organizations because of its impractical and unprofessional business environment and non-fail-safe configuration, it's still used today. The reason peer-to-peer networks are not used commonplace in most organizations is because there's very little version control available. If one file is updated on a specific user's computer, it's very hard to control whether the file is available on another computer at the same time in the same version. If a coworker wanted to work on an updated document that somebody else had been working on, having that file synchronized across all the different clients in the network, it would be very hard to verify this would be able to happen. Client-server networks maintain a central location, both physically and logically, in order to control security data and applications. This greatly reduces the risk of file access problems and security concerns. An example of client-server networks in use today is twin-tier client-server network environments. Processing is done on the server in this case, and the data is sent to the workstation to be processed on the client end. The server determines what data is needed on the client end and sends only the information necessary, reducing bandwidth. Three-tier client-server networks involve processing which is done on multiple servers, and this further reduces the amount of bandwidth that is needed to consume information to send to users on the other side. Primary design for client-server network uses a three-tier client-server network. In many cases, application servers are used in conjunction with network-attached storage and database servers. Client-server architectures were developed to answer interoperability problems. It's in the nature of client-server network architecture to solve problems related to mainframe computing in our common practice in older enterprise-scale networks. Instead of having to rewrite documents and transcribe information in files so that they would run on different networks, files can be interchanged between workstations and servers without problems. It has taken nearly 2 decades for proprietary protocols to begin to fade, and there are still many protocols that still prevent interoperability between different manufacturers. Standard protocols became increasingly relevant when Apple, Microsoft, and Linux systems became used on the same network for different needs. This is designed to allow users with different needs and the different operating systems accordingly to work on the different systems and be able to interact on the client-server network without problems. Instead of having to set a uniform standard for the operating system used for an organization, such as all Windows, all Linux, or all Apple, we're able to use multiple operating systems and applications and just communicate using simple mail protocols, security protocols, and internet working access protocols. So a lot of the advantages from client-server networks involve the processing which is done in one or more servers which distributes resources. As mentioned earlier, sending databases, CAD drawings, models, and multimedia files over a local or wide area network causes a substantial decrease of available bandwidth for other users, so it's an advantage to use a client-server network in this case. Processing files using multiple servers, either standalone or in a cluster, allows smaller files to be transmitted to the workstation where the request is being processed. Data is stored on one or more servers, which are generally secure in comparison to clients. Storing files on workstation hard drives is not a secure or professional manner of storing data because it's available only to one user rather than the organization which its property it belongs. Having a file system secured physically and logically organizationally can ensure that the workstation is in operable condition and will be able to access the file from the server in the next workday. File and database updates can be done only on the server, which allows for the file version to maintain the current status. For example, if I open the file on my workstation, edit it, and then sent it back to the server, other users would be able to access the updated file from your workstation without there being a conflict on they having to access it off my PC. So if I shut down my workstation at the end of the day, which had only the updated file on it, all the other users who wanted to work on it at different hours wouldn't be able to do so. However, in the client-server method, the client is able to store their updated version of the file on the server, which in turn allows other users to access it at any time as long as the server is accessible. Client-server architecture provides much greater interoperability with clients, on par with peer-to-peer network architecture, but with several advantages. Like peer-to-peer networks, client-server architectures allow great interoperability through the use of standardized protocols. These protocols determine the means of communication on a basic level, which allows a very different operating system, applications, and hardware devices to communicate using a simple set of instructions. Unlike mainframe environments, where devices must be designed specifically for use on a specific network, client-server and peer-to-peer networks allow for the use of multiple protocols and hardware devices, as mentioned previously. Market domination is no longer as much of a threat where networks are concerned. There are few networks that dwell on one manufacturer anymore. And unless they are being provided a stipend from a local or federal government, they're able to go with the lowest bidder or best equipment to suit their needs. Proprietary solutions are necessary for very few corporations, generally within niche groups, that work with smaller bodies of network users. Unfortunately, there is still a substantial number of problems with proprietary networks concerning interoperability. But if there is no need for interoperability, then proprietary configurations may be used without causing stress on network users. Total cost of ownership, or TCO, could be decreased using client-server network environments. If an organization does not need to run Windows on their servers, then they could feasibly switch to Red Hat or another Linux distribution that would reduce their operating costs without sacrificing any features. By reducing TCO, companies can in turn invest money in expansion, additional technical resources, etc., or what's needed. Reflecting, it is important to note that using client-server environments is an alternative to mainframe systems or peer-to-peer networks. They can greatly enhance corporate networks and organizations and their technology services.
What was